Welcome back to DigiTech Dynamo. In today's video, we're going to dive deep into a sound detection module that I've been working on. This module includes a few key components such as resistors, a microphone, an IC393, and a 100K ohm trimmer preset. We'll be using it for voice control applications with Arduino. I'll also walk you through how I trace the pins and examine the PCB under a microscope for a better understanding of its circuitry. Here's a breakdown of the components in this sound module. Microphone, the core component responsible for detecting sound waves. Resistors, these help regulate the current in the circuit. IC393, this is the heart of the module. It's a comparator IC commonly used in sound detection circuits. 100K ohm trimmer preset, this adjustable resistor allows fine-tuning of the module's sensitivity to sound. Let's take a closer look at the IC393. This is a dual comparator integrated circuit, which means it can compare two input voltages and output a high or low signal based on the comparison. It's ideal for sound detection because it can detect even subtle changes in sound intensity and convert that into a digital signal for our Arduino. The IC393 has 8 pins, and here's a quick pinout. Pin 1, output of comparator 1. Pin 2, inverting input of comparator 1. Pin 3, non-inverting input of comparator 1. Pin 4, ground GND. Pin 5, non-inverting input of comparator 2. Pin 6, inverting input of comparator 2. Pin 7, output of comparator 2. Pin 8, VCC, power supply. This IC is key to the module's ability to detect sound and convert it into a signal that can be read by a microcontroller like the Arduino. After carefully examining the module under the microscope, I traced the connections from the microphone and resistors to the IC393. Here's how the circuit is laid out. The microphone picks up sound waves and converts them into electrical signals. These signals are fed into the IC393, where the comparator processes them. The trimmer preset is connected to adjust the sensitivity of the sound detection. By rotating the preset, we can control how much sound is needed to trigger a signal. I've created a diagram of the traced pins to make it easier to understand how everything is connected. This helps ensure that when we interface it with the Arduino, we can use the right pins and get accurate results. This sound module is versatile and can be used in various applications such as voice-controlled systems, control lights or appliances with voice commands. Clap switches turn devices on or off with a clap. Sound-activated alarms trigger alarms when sound is detected, useful in security systems. Robotics use sound as an input for robot control, like starting or stopping actions based on sound cues. And that wraps up our exploration of this sound module. By understanding the components like the IC393 and how the circuit works, we can easily integrate it into our Arduino projects for sound detection and control. Stay tuned for more tutorials where we'll dive into building real projects using this module. If you enjoyed this video and found it useful, don't forget to like, share, and subscribe to DigiTech Dynamo for more electronics and Arduino tutorials.